So hey, welcome back to Building Microservices with Go with me, Nick Jackson. I hope you've had a really great week. And I'm kind of going to continue the series today. So what are we going to start to look at? Well, we're going to kind of start wrapping up RESTful services. Over the last sort of few episodes, what we've done is we've looked at some things like JSON decoding, and we've kind of looked at how we can do validation and documentation. What I want to start to look at is, well, how do we kind of handle some edge concepts around this? So multipart form requests is one, and the other, well, that's going to be gzipped data. So I think one of the important things about multipart is that I think it's somewhat deprecated. Let's take a look. So multipart requests, this is kind of, I think, back when everything in the browser was static HTML. So you had a very kind of standard approach of doing things. You didn't have the opportunity to use a lot of the JavaScript frameworks like you did now. So what you would do is you would basically just kind of put a file element into your HTML, and you'd have a button. So you'd be using HTML forms. You'd push it, and the browser would do the rest. What the browser would actually do is it would send forms in a data format called multipart form data. And multipart form data, what that was, it was kind of that HTTP data. So it's a combination of text and binary information, but it would separate it using these boundaries. So you can see here that here's a request, and you could have read this straight off the wire in this format. But you can also see that it's separated. So we've got things like a field, and that would correspond to an input box on your HTML form. And then you would have things like a file, and a file would you'd be using the input file box, but you get things like the file name, and then you'd get the binary data for the file, and all of that would come through the request. So this is still technically valid today, but I think commonly people aren't necessarily using plain HTML to post data. It's also not RESTful. But just on the edge case that you need to take a look at it, let's see how we could implement handling multipart in our API. So over to our API. So what we are going to do is we're going to add a new route. And it's going to be a post route, but what we want to be able to do, rather than handling the files in a kind of a RESTful way, we want to be able to handle them using multipart. So let's first just create our new route. Now, because multipart, the request is actually going to have the file name, and it's going to have the ID and all of that sort of stuff in it, we don't need to necessarily capture that here. So we're just going to have a post which goes to the route path. And here what we're doing is we're handling that with the serve HTTP function inside of our handler that we wrote last time. Let's dig into there and start refactoring. So the handler is designed to specifically just deal with a sort of a RESTful approach. So let's first rename this. So let's just call this, let's call it upload REST. And we can, again, we're just going to preserve the signature, but we're just renaming this for the time being. And then what we're going to do is we're going to add a new function, and we're going to call this one upload multipart. Okay, so F files upload multipart. And again, it's going to take the same signature, just the kind of that standard handler functions, HTTP response writer, and an HTTP request, which of course reference, and that like that. Okay. I'll put the comment in later. Upload multipart something. Right. So now we've got our function defined. What we can do is we can kind of update our handlers to reflect that. So let's do that. Okay. So we're going to do upload REST when it's a RESTful, and when it's multipart, we're going to call upload multipart. So what do we need to do in order to handle multipart requests? So as we kind of saw in the sort of the documentation, you can see that a multipart request is going to have a body which is containing all of this information. So does that mean that we have to parse out all of these boundaries ourselves? Not too much. Go has a bunch of stuff for doing this. On the HTTP request, what you actually have is two methods: parse form for dealing with sort of URL encoded forms, and you have parse multipart form. So we can use these methods. So parse multipart form, what is that going to do? Well, it's going to read all of that multipart form data for us. It's going to automatically start breaking up the body on the boundary, and it's going to store it for us into a collection that we can later reference. So this is where we want to start. So let's put this into our code. All right, so we're going to parse the form. So it's going to be HTTP request, parse form, multipart form. Sorry, because we want to be dealing with a multipart. Now, max memory. This is if we look at the documentation, this is the amount of data which will be held in memory. The rest is going to be written to temporary files on a disk. So reading from memory is obviously a heck of a lot faster than reading from a file. So you can make that decision of, well, how much memory do I want? I think if you're expecting a file, a large file, you probably don't want to allocate 10 gigabytes of RAM for every request. Well, maybe you do. Maybe you just got a lot of RAM. But I think kind of in terms of max memory, what you want to be kind of thinking about is what sort of size of fields am I anticipating? If you've got small boxes, text boxes and things like that, that's probably where you want to be thinking around how much memory to allocate. Everything else, you want to dump that out into a file. So I think, I don't know, what do we want? Maybe a 128K or something like that. I think that's probably a decent sort of place to start. So max memory, let's do, I don't know, what, 128 times 124. Oops, something like that. Now this returns me an error if I'm unable to parse the request. So in the instance that we don't have a multipart form, or that we can't actually return this information, we're going to get an error back. So we can return that response back to the user. So we're just going to do standard pattern. If error is not equal to nil, then what we're going to do is http.error response writer, our message, I don't know, expected multipart form data. And then we can actually just do our error code. So it's going to be http.status bad request. And then we'll just return. The other thing we probably want to do is let's just log something out to our error log. And we can just say expected, oops, let's just say bad request. We can type anything in here later on. All right. Now, let's make an assumption we do have the form. So what can we do with this object? Well, now we've called Parse multipart form, what we have available to us are the functions which exist on the request, such as form value and form file. Let's take a look at those in the docs. So form value and form file. Just going to scroll up, wishing I had an index on the left-hand side, but I don't. So I'm not going to complain too much. There we go, form value. So form value is going to return the first value for the named component. So again, if you remember that multipart, then you have a name here. Okay, this is part of the kind of the header for each of these sections. So form value is going to return the value, this bit here, for that given name. Now, it's only going to return you when the type isn't a file. So it's just going to return the textual ones. In the instance that we do actually have file content, well, then that won't be returned by this collection. So let's implement that. So we can get our ID because our form, we're going to look at submitting with an ID. Actually, let's take a look at the form. So what we have in terms of a form is just something in React.js. I really dig React.js. I find it very, very easy to use. And it's actually really, really complementary to RESTful services. So this HTML snippet here, this is kind of what a standard form would look like. And I've just written some React.js to do that. I'm not going to dig into that. I'm tempted to do a video series of React.js for Go developers, but maybe stick a comment in the thing below there if you'd like to see that. But I just want to run it. So I'm just going to run my form. I'm using yarn, so I can just do yarn start. That's going to run there. And you can see our little React.js UI. So this is the same UI as we were looking at last episode. It's retrieving the products from our product API. But let's take a look at the admin. So our admin is really simple. We're going to have a product ID, and we are going to choose a file. That one will do. And then when I submit this, what I'm going to do is that will create a multipart request, and it'll submit it to my backend server. So back over to that backend server. So we're gonna be able to get these values. So we're going to be able to get the ID, and we're going to be able to get the ID from r.formValue. Oops. Form value, and then the name. Well, it's called ID. That's what I have the form identifier here, just in React. And we can use this ID. So let's just, for now, let's just log it. Log.info, and we're just going to say process form for ID. And then I can choose my ID like this. Okay. So now if I run my code, so let me select my product API. Let me just go to the files API. product images, and then I'm just going to go run that. Okay, already in use because I'm running my other API on port 9090. So let me just change that in the defaults there to 9091, and I'll run that again. Okay. So the API is now running. Let's go over to our form and let's hit the button. Okay, let's check out what's going on here. So we're going to go over and we're going to look at the console. And we can see that access to blah, 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 localhost 1991 from origin, localhost 3000 has been blocked by cause. Remember this old chestnut from last time? Well, let's very, very quickly implement that into our file server. So again, you can check out that video where I explain cause in more depth, but what I'm going to do is I'm just going to import that handler pattern. Handlers. Then down here, we're going to do a new cause handler. Go handlers dot cause, and that takes a cause option. And we want the origin, allowed origins, and I'm just going to pass that a string of star because I'm happy for any origin. Now I've defined my cause handler. I can just make sure that that wraps my main router. Okay. So let's run that again. And then back over to our web UI. So submitting our form. Okay, so that's worked, okay? So you can see we've submitted the form. Let's take a look at what the browser actually sent there. So you can see the headers. You can see that it's, let me zoom this up. You can see the headers. You can see the content type, multipart form data. There's the boundary that we were using. And then you can see the form data itself. So I have an ID of 1 and I have a binary file. Nice and easy. So this is working great. So far, so good. Let's go over to our code again. We're going to stop that because we're going to make some more changes. So what we need to do is finish the implementation of this. What about the file itself? Where are we going to get that file from? Well, we're going to get the file from the files, funnily enough, right? So files, let's have a look at this. So r dot form file, and again, a key. Now, form file returns multipart file, a file header, and an error. Okay, so file, multipart header, and an error. So I'm guessing, well, if it doesn't exist, we probably want to just return an error. So let's just put a generic error in there. But what is this? Okay, so file header. Let's take a look. So file header is actually in the MIME multipart package. And if you remember back, and let's just take a quick look at that. But that header that's going to be sent with each of the parts has things like the content disposition. It has things like a name. So what was the name of the field that was on the form? And then you have the file name. So I'm getting all of this information inside of the the file header struct here. So in terms of my code, what I need to do now is I need to save this file. Well, I need to do one thing first, because unlike when I was defining things with my RESTful approach, with my RESTful approach, what I can actually do is I could specify that my ID was actually a number. And the validation that's built into the MUX router is going to ensure that that was the case. I'm not getting that same validation here. I can't trust the input that's coming in. So I need to validate that I do actually have an ID number. So let's do that. Let's do that first before we start processing. I'm just going to comment that out for the time being. Right. So we need to convert this into an ID. So how can we do that? Well, what we can do is we can use stringconv.a to I. And stringconv a to I is going to return us an error and an integer. Actually, I can look at this here and I can say string error. Or we'll call it ID error. Right. And then we're going to get this error here, right? So now we've got both our bits. We can do another bit of validation. So instead of just saying if this error is nil, why don't we do a another error here as well, and we can kind of say, well, if ID error is nil. And then we can give a nicer message here. So instead of multipart form data, we can say expected integer ID. So I'm actually having to do quite a lot more work than I did when I just looked at the Gorilla sample. And then we can say here expected file. So but we kind of, once we get through all of that, we can actually start to save our file. So we can use the same sort of function that we used last time for saving the file. And let's just implement that. So we can then just say f dot save file, and we're going to pass the ID, and we need the ID as a string because it actually forms part of our path. So we can convert it back, or we could just read it again. And I didn't think about that very thoroughly, did I? Never mind. And then we have the file name. So where are we going to get the file name from? Well, the file name comes in this header collection. So there we go. We can see I've got the file name. Then I pass it my response writer and my request as normal. So this is now going to save my file. There is kind of some protection in this. So if we again look back at the kind of the setup for multipart reader, then multipart reader will actually, the form parser will only read requests of a certain size. If we want to read requests greater than the default, which I think is about 10 megabytes, and I'm just going to find that in the documentation for you. Then, so there we go. Max byte reader, 10 megabytes. Then we can override this behavior, but I think 10 megabytes is fair for this application. So let's just leave it. So we've got that form file there. Let's save this up. What's this complaining about? Cannot use as files. Oh, of course, because we need to do a little bit of refactoring. So in our save file, what we are doing is we're passing the request.body. We don't want to do that. So we're going to pass our file. And here, let's just refactor this HTTP request to take an IO read closer. And let's just call that F. Oh, of course, more than one F. FF. We'll just go reader IO dot read closer. We don't need the body there because we're now explicitly doing that. And then here we've just modified the signature, so we just refactor that ever so slightly. But this is pretty much all we need to do. So we can look across. Let's go back, let's run our application, and then let's look at this code again. So go run main.go. So I'm running my API server again. I go to my front-end application in my web browser, and I'm just going to upload. So there we go, uploaded form over here. And you can see that I've saved the file for product ID 1, and the path is holding. So if I look in my folder where I'm saving those files, there you go. That's the file that I've just uploaded. So that's all you need to do to implement multipart form parsing in Go. Some of the things that you might kind of be thinking about when you're looking at this, and you might be like, well, okay, this is fairly straightforward, but if this parse multipart form, this is writing all of that information to a disk. What if what if I get a bad ID? What if the ID of the request is I don't know, a string, doesn't correspond? Then actually Go is going to the effort of writing all of that information file to the disk in the background. Yeah, I mean that's kind of true. This is kind of one of the, I suppose, the disadvantages of using the multipart form approach. You can, of course, implement a lot of stuff yourself. So everything that's going on inside of parse multipart form is actually pretty much just using the MIME multipart package under the covers. So all of the things that's done automatically, if you wanted to, you could parse yourself. So for example, rather than reading that file and getting it as a file which has already been written to a disk, you can pick up that file as it's read in as a stream from the actual content body there. I kind of thought about doing this, and I'm thinking, well, isn't that a better pattern? But when you kind of start to look at it, the ultimate problem is that you end up with the same problem. You'll receive a file, you don't know what the order is, you can't guarantee that you're going to read the file ID before you read the file body, so you end up saving them all both anyway. So actually, multipart form is a necessary evil. Maybe. But, you know, I think it's pretty straightforward. So just as a quick recap. So what we've seen in this episode is we've just seen how easy it is to use to upload a multipart form. In all honesty, as a sign of a summary, I would still recommend taking a RESTful approach. I think with kind of modern code, you have more control. You're not just doing a very straightforward post. What you actually have is the ability to manipulate and define the request yourself. So you're doing an XHR request in JavaScript. This is kind of the typical way that things are going to work. So in this instance, calling one or more APIs to be able to submit and upload the data, well, it's going to be pretty standard. all of the data is going over HTTP, so it's going to be, or HTTPS, so it's using standard TCP as the kind of the base level, and then of course you're going to be using either the HTTP protocol or the HTTPS secure protocol. So none of that is any different. Yeah, I think that's it for now. Next time, and the very, very last of the kind of the series on REST, it's going to be gzip. So I'm going to show you how to gzip these files. How can we make it more efficient to download our files? And then we're going to be digging into gRPC, which I think is going to be interesting. Now, what I'm also going to start doing, and I'm not going to do this next week because I'm kind of away next week, but starting from the week after, I'm going to start looking at kind of a side series. It's not going to be building microservices with Go, but it is going to be all things microservices. And in those videos, I'm going to look at some things that folks might find interesting, such as how do you load balance multiple services from a Kubernetes ingress. So that's actually going to be the first in that video series. I'm going to take you through what I think are the kind of the two of the nicest bits of software out there at the moment that you can run on Kubernetes to load balance your, well, not load balance your service, route traffic to your various different services. And we're going to kind of continue along looking at some of those things. And that'll be the midweek series. We're obviously going to continue with building microservices, and there's a lot more to cover. But doing it this way, it means I can kind of give you a little bit of side information because you may already be microservice practitioners, but maybe not necessarily so much with a Go. For now, I want to thank you again for watching. I want to encourage you to like and subscribe so that you can keep up to date with the latest videos. And yeah, it's all going to be great. And I'm all looking forward to teaching you. So for now, thank you so much.